You're listening to Making Waves, Fresh Ideas in Freshwater Science. Making Waves is a podcast where we talk about new ideas in freshwater science and why they matter. Making Waves is brought to you with support from the Society for Freshwater Science. Thank you for listening in today. I'm Tim Cline. Joining me for this podcast is Mathis Messager, a graduate student in the School of Aquatic and Fishery Sciences at the University of Washington. He is the lead author on a study that was recently published in Nature Communications titled Estimating the Volume and Age of Water Stored in Global Lakes Using a Geostatistical Approach. In this study, they used new tools to estimate the number, size, volume, and residence time of lakes globally. He's here to tell us a little more about the research and the importance. Let's first start with a little bit about the research group. So this was a collaborative paper coming out of a group of researchers at McGill, correct?
Mm-hmm. Yeah, we were all part of actually the same lab, the Global Hydro Lab, we call it, at McGill. And so the PI was Bernhard Lehner, and all the other members of all the other authors were actually students in the lab.
So the core issue for this paper is that lakes are hard to count.
Yeah, very hard to count.
And we need to get a better idea of how many there are and how big they are so that we can scale different processes. Can you talk about this a little bit more?
Yeah, I think that we are, with remote sensing, we've become pretty good at counting the amount of water that's on Earth. But what's been really hard was actually to count how many lakes we have, because we have wetlands, we have rivers, we have estuaries, and so it's really hard to differentiate between a lake and any other kind of surface water. So I think that a big objective of this paper was to produce a lake-only database to be able to essentially differentiate the role of lakes from other surface water. And that took essentially a lot of manual corrections for several years. And a lot of its strength, I think, of this created database would be potentially to combine them with those large-scale, temporarily more fine databases and kind of combine them to have an idea of what's a lake.
What specifically is important about quantifying the number of lakes? You mentioned in the paper a few things like water budgets, upscaling carbon budgets. Can you tell us a little bit more about the importance of an accurate count of the number of lakes?
Yeah, for sure. I mean, lakes are more and more we're recognizing them as kind of a ubiquitous element of the landscape. In Canada, for example, they cover 9% of their land, which is quite huge. And so you start to think of everything that goes on lakes and how lakes or the shoreline of lakes is the interface between the landscape and the water system, essentially. And so in 2007, it was Cole and Prairie had this paper. It was plumbing the carbon cycle. And I think that that's essentially what we're trying to do is, add these lakes in these global models of hydrology and climate change and see how that changes our results and how we can refine our estimates. And so lakes are really important also in, modeling how all kind of elements go through the landscapes, whether that is nutrients or pollutants. And so including them in a hydrological cycle with rivers allow us to see how all these elements go through the landscape.
It seemed to me when I read through the paper that there is an emphasis on small lakes. I think this stems from a common misconception, not necessarily by ecologists anymore, but I still think it's out there, that big lakes are very important compared to small lakes. But we now understand that small lakes per unit area are more important for most processes. I think there's a line in the paper that states you cannot just multiply the total surface area by a rate and come up with an estimate of your process of interest, because each lake has different rate. So it's very important to really understand this distribution.
Yeah, exactly. I think that even though, large lakes are very unique and they have their own processes, but I think that we need to have an idea of the very specific processes that take place in smaller lakes. And the paper, it's a little difficult because our smallest lakes are 10 hectares, and some would say that these are not small lakes, But when you see that at the global scale, that's the smallest we can go, then that shows how much we need to work on getting more data and more understanding of how these small lakes work on the global scale.
Let's talk a little bit about your approach. In the past, this has been done by assuming a distribution like the Poisson distribution and then extrapolating from that. But you have some remote sensing data, and you are going to try to quantify lakes from that. Can you tell us a little bit more about how you did that?
Yeah, the database that we produced beyond the estimates was essentially trying to stitch together in the most consistent way possible about, I think, 8 main sources of data. And so most of it, area-wise, was actually the satellite mission that was launched, that was conducted in 2000, that essentially captured the topography of the world. And then they had like teams essentially looking at all of these images and tracing manually the shoreline of all these lakes, of about like 800,000 lakes, if I remember well, all the way up to 60 degrees north. And so this was kind of like the biggest chunk in this database. And then we added data for northern Canada, Alaska, northern Europe, Siberia, and all other kind of places where we could fill in with other databases. And so a lot of the work actually consisted of making all this consistent and have the same resolution as much as possible to be able to then run our models on something that we think is the most consistent possible, covering all of the land area.
The other unique thing about this paper is estimating volume, and this has been a very hard thing to quantify in the past, but you use landscape features around the lakes to then estimate the shape and volume of lakes.
Yeah, the volume, I think the volume and the residence time were really kind of like the most exciting parts of this project for me. I focused, most of my work was actually on coming up with these models of volume, and our idea at the beginning was to create a more mechanistic idea of volume where we would extend the slope within the lake to reproduce a bathymetry. And sadly, we found that coming back to simpler kind of average slope within buffers was actually the most performant, or actually the most parsimonious, given the data that's available at this time. I think that in the future, you know, if we wanted to have even better volumes, we would need more understanding of how different types of lakes are shaped in relationship to the landscape and where these lakes are, because we have very little understanding of what type of lakes are where, essentially.
So I pulled a few striking numbers out of the paper. You came up with an estimate of 1.4 million lakes globally. These are natural lakes greater than 10 hectares. Combined, they have 2.7 million square kilometers of surface area, which is 1.8% of the land surface area. 7.2 million kilometers of shoreline, which is 4 times the global ocean coastline, and 182,000 cubic kilometers of volume. This last one's a little more difficult to put in perspective. And of course, you measured residence time, which was the other big part of the study, and the median estimate for the residence time was 456 days. Those are just a few fast facts, but what were the big takeaway results that you think came out of this study?
I think that I was amazed by, in the end, how much these largest lakes contribute to the global volume. And I mean, you know, another fast fact, you know, is that 85% of the global volume is in the 10 biggest lakes. You know, it's quite unsettling. But at the same time, when you think about processes and you look at shoreline length or area, then you see that actually small lakes matter a lot. And given that we stopped at 10 hectares and that you still have over 60% of the world shoreline in lakes under 10 square kilometers, then you start really thinking, okay, if we included the smallest lakes down to like 1 hectare or even 0.1 hectare, then really the great majority of the interface between the landscape and the freshwater system through lake shoreline is in small lakes. And that's where I think it matters a lot for all these kind of nutrients and carbon cycling that we're most interested in nowadays.
That got me thinking about another question. Were all the lakes permanent? Is there any way to deal with seasonality?
Seasonality is the really tricky thing in this database. One advantage that we have is that a lot of the data comes from topographic maps. We're all digitized from topographic maps in many regions, so that generally topographic maps actually are like a longer term compilation of knowledge on the geography of a region, and so you tend to have a better idea of what's seasonal versus what's permanent. I think one good way that we could actually have a better idea of what's seasonal would be to combine the kind of more curated database that we created with good remote sensing data. Like, I don't know if you've seen, but in December of last year, the European Union agency with PICALE published, I think it was 30-year yearly world water extent. Essentially, they had estimate for each pixel, 30 meter by 30 meter pixel on Earth, of the seasonality of water in that location. And so I think that really interesting analysis could be combining these kind of estimates with ours and saying what's the percentage of the world that's seasonal, and also how much water we might have lost in the past 30 years in terms of volume.
Did the results of the study improve on our understanding of the number of lakes? I know the volume and the residence time estimates were novel, but did this improve on the distributional assumptions we've made in the past?
So the Pareto distribution is always very tricky, and I think it's still at the center of a lot of controversy in the field, whether lakes follow kind of power law. It wasn't really our goal to prove this in the end. I think we used that distribution because it seemed to fit our data, and we tested that. And it was a convenient way to make estimates of how many smaller lakes there might be. Some people focus much more in depth on trying to prove or disprove the existence of a power law distribution. In our case, it was mostly like, okay, it seems like it's fitting one, so what does that tell us about lakes? In terms of volume, was another thing that was surprising is that previous estimates were pretty good, and I think that resides in the fact that most water is in big lakes, and we've known the size of big lakes for a long time. But, I mean, the beauty of it now is that we actually have distributed it over the landscape and over watersheds, and we can now actually implement these estimates of volume in models and see how that plays out in the global hydrology, because this entire database is actually included in a river network. We've combined essentially our lake database and we've linked it to a river database, and so now we can just run cycles, which is the most interesting part of it.
Is there anything else you want to add about this work?
Personally, for me, it was mostly a really great learning experience, and I was very lucky to be doing this as an undergrad, and that's what essentially brought me to be here now at the University of Washington and really enjoying doing science. And I think that was actually just possible because there were systems in place to allow me to do this kind of research through funding and mentorship. So I think that was an exciting part of it.
Yeah, I think it was a good opportunity for a young scientist, and you certainly made the most of it. Thank you for joining us.
Thank you.
This podcast was brought to you with support from the Society for Freshwater Science. For more information about this speaker, the podcast, or the Society, please visit www.freshwater-science.org. Be sure to join us each month for more fresh ideas in freshwater science. Thanks for listening.